Hello students, this is Miss Neff. So this is a practice for level 2, um, triangle similarity. This is learning target 9. All right, so a review real quick. Remember what similarity means. So similar right here. Remember, similar means all corresponding angles are congruent and all corresponding sides are proportional. What that means is we're going to be given like two triangles. They may look, different, but there's always two triangles. And we want to check to see if they're similar. And remember, one way we can do that is we could measure all three sides of the triangle, and we can measure all of the angles, and then we can compare them. But then you have to take the proportions of two of the sides, and that means 6 pieces, right? 3 sides, 3 angles, and you'd have to compare them. Or you could do the shortcut. And the shortcut says there are 3 shortcuts to tell whether two triangles are similar. 3 shortcuts are AA, SAS, and SSS. These are called similarity theorems, or similarity, well, AA means 2 angles of one triangle are congruent to 2 angles of another. Third angle has to be congruent by the triangle sum theorem. Okay, and remember the triangle sum theorem says that if you measure all of the angles of the inside of a triangle, they should add up to 180. They have to add up to 180. So if you know 2 of the angles, you can add them up, subtract them from 180, bam, you can find the third angle. So all we have to do is prove that 2 angles of one triangle are congruent to 2 angles of another triangle. Done. So let's take a look at that. So notice you have 110, you have 107. We don't know anything. We do know this angle R is the same angle for both the small triangle and the big triangle. So we have angle. We have one angle for both triangles. This one, they're different. And we have no idea what these are. We don't know. So this one would be not similar. We just put not similar. We don't have enough information. Maybe they are. Doubt it. But so we just put not similar because we don't have enough information. Now this one, on the other hand, we know that angle D is the same angle for the small triangle as for the big triangle. So we know, and then they give us angle P right in here is 59 degrees, and angle B right in here is also 59 degrees. So we have angle, angle. Not these two. This is one angle here. One angle of one triangle congruent to one angle of another triangle. And the second angle is angle D is congruent to angle D. So yes, by AA. This is another one that would be angle, angle. These two angles, angle C, are congruent to angles. They are congruent to each other because they are vertical angles. These are parallel. Because they are parallel, we can make a Z, and that is going to give us alternate interior angles are congruent. So AA similarity statement. So this is another one good for angles. Remember, they're not giving us any side measurements. They're only giving us angle measurements. We know that angle S over here, angle QS, whatever that is, angle ESF, those are congruent. They're vertical angles. So we have A. Now, if I have a 61 over here, I'd better have a 61 over here. We don't. So I go to the other one. I have a 45. One of them better be a 45. We don't. These are not similar. We can't prove that they're similar, so not similar. Those are the easy ones. Those are AA. The harder ones, you're going to have to show 2 sides and the angle in between them, or 3 sides. So for instance, over here, the next one is SSS. We're going to have to look at 3 proportions and make sure that all those 3 proportions are the same. I'm going to skip that one for right now because that's a lot more work than this one, where we only have to show 2 sides are proportional. Okay, so first I'm going to show you a bunch of them that are SAS. Notice they give us 2 sides of a triangle and the angle in between them. We're going to be looking at SAS to prove that these 2 triangles are similar to each other. AA, SAS. See, 2 sides of one triangle compared to 2 sides of the other triangle and the angle in between them. That's AA. This one, they give us 3 sides of the triangle, SSS. 3 sides of the triangle, SSS. 3 sides of the triangle, SSS. 3 sides of the triangle. They give us an angle. Angle. This is going to be AA. Angle, angle. SAS. 3 sides, SSS. So now we know what we're looking for. SAS. Okay, so now we're going to actually do the work. So we're going to start with an SAS. There we go. So to prove that these two triangles are similar, remember we have this triangle and we have this triangle. We have two triangles. We want to compare them by looking at the corresponding sides. That means I'm going to take a proportion. I'm going to make this triangle 1. I'm going to use numbers that go triangle 2. This is triangle 1, triangle 2. Okay, in triangle 1, it doesn't matter which one's which. I'm going to call this one triangle 1 and this one triangle 2. It doesn't matter which. It's just to help us label and organize. Okay, in the top one, I'm going to put the smaller number. In the bottom one, I'm going to put the bigger number. Again, it doesn't matter. I can put the bigger number in the top and the smaller number in the bottom. Doesn't matter. It's just a matter to organize it. Okay, 88 is smaller. I'm going to put that in the top. 16 is smaller. I'm going to put that in the top. 143 is bigger. I'm going to put it at the bottom. 26 is bigger. I'm going to put it at the bottom. If these are the same as each other, they are similar because the angle in between, this is congruent because of vertical angles. Okay, so I'm going to put a question mark in between them because I don't know if they're congruent. I'm going to take my calculator and it turns out they are the same. So that means if the proportions are the same and the angle in between them is congruent, then yes. How do we know? By SAS. And what is the congruent similarity statement? We'll do that in a second. You know what? I'm going to go ahead and skip the rest because this is all review. If I want SSS, I need to make sure all 3 of the proportions are the same. They all have to be equal. So SSS is a little bit more work. How do we know? What is the congruence similarity statement? The similarity statement is here. See the similarity mark? This is called the similarity statement. Make sure you put a triangle there. They do E first. Because they do E first, we're also going to take E first over here. They did D. So I'm going to look at ED. ED was my 143. My 143 were, because sometimes they flip them. So this is the smaller, this is the larger, this is the smaller, this is the larger. So if I go 143, I want the smaller on the other side. I'm going to start at E. I'm going to go to Q. I need, oops, ED. It was a larger one. I want the larger one, 26. So that is ER. Q. It has to go in the same order. So if it goes ED to the large side, I need to go ER. I need to also talk about the large side. They need to be in order. Okay, so that's pretty much, oh, level 2. There's one more thing. Sometimes they're going to ask, what is the measurement? They're going to tell you they are similarity. Find the measurement of 1. Okay, so this one's a little bit different. This one they're telling us they are similar. If they are similar, then you know they give you, first of all, they give you the similarity statement. Similarity statement is going to be very, very powerful because the similarity statement tells us that if you take the distance between U and V, it is proportional to the distance between U and B. The distance between V and W is proportional to the distance between B and C, and the distance between U and W is proportional to the distance between U and C. So UV, UB, VW, BC, UW, we don't know. So it turns out we don't need this because they don't give us any information. Cross multiply. It says find the missing length. Yes, we're good to go. That is the missing length. If they give you something a little bit harder, oh, by the way, that's a level 2. We'll stop there.